Wow. It's a big group. Self-study, although C++ is an exception, especially in the spring semester, so many, I find it useful to hold a review session. So I'll do that at this hour each week to go over the upcoming project, maybe this week and the next week out, so that you can work on things. So the textbook, I refer to particular projects, but I change them, right? And so I will want to talk about those changes. They override what's in the textbook. The projects for the first few weeks are actually have choices as well. So I will talk about each of the choices as needed. Later on in the semester, everybody does the same kind of project. There aren't really choices. But early on, you know, one might be doing a payroll program, and the other option is estimating pi. So they're wildly different. You know, so those of you from physics, you should do the pi one. Okay. Those of you not in physics, maybe then the payroll project makes more sense. But, for example, the pi project is actually a good example of software written to do numerical analysis. And so that's why I want to take a little time with you. It isn't just learning a little bit of new syntax. You'll find that C++ is very similar, in the same family as Java. However, it does have some nuances that are different than Java. And that's what I wanted to take some time and go over here. I'm out of extra C++. There's an extra, I'm out of the syllabus. And this is only the first 2 pages of the syllabus. You need to go on and get the rest of it. Okay. So it is self-study. So this hour is not required. I just highly encourage you to come. I am going to videotape it. How quickly I would put that up for later usage by you all, we'll see. I am actually recording it more for the purposes of the online version of this in the summer, which who knows where around the world somebody may be taking this class. So I want to give them the same opportunity to get the extra explanation that I feel that it's worth going over. I could let you flounder and try to solve these projects on your own, only for me to tell you to resubmit. Okay, and I want that to be an efficient process. So I would rather you get it right the first time, wouldn't you? Okay, so that's why I think it's worth the 30, 45 minutes that we'll spend here so you understand really what I'm looking for in the project. You will have 2 shots at submitting these projects. Okay, the first one will be due on Fridays typically. And I will review it in a timely way as I can. I've got 30 people doing self-studies, and I'm not sure, and plus 3 other classes full-time. So I shooting now or whatever. See how this plays out. So I will do my best to review within a week, within a few days. I will post the review. I'll take your source. I will create a PDF. I will mark up the PDF with my review. If they're just minor things, I will give you full credit. Okay? So a project will be worth 6, 8, or 10 points. So if it meets a bar, I will have this kind of mental point at which I think it's good enough to just go on. You will get all 6, 8, or 10 points. If it has problems, I'll maybe give it 2 or 3 to encourage you to resubmit. If you don't resubmit, then you get the 2 or 3. Right? So if you don't resubmit, that's your choice. You have 1 week to resubmit after I do the first review. Moodle will give you an email when I review it. You will get that email with my response, with the grade, and a pointer to the PDF that you should look at. And you should look at every one of them. Even if you get full credit, please look at the PDF because there may be things that I'm saying you should apply to future ones. You know, maybe your documentation is a little bit under par. I will point that out, and I expect you to raise that level. And if you ignore that, then I might call you on and make you do a resubmit later on. Right? So please look at the reviews and be sure there aren't other things that I am asking you to attend to. So you have 1 week after, after the review, if I say please resubmit, you have a week to do that. Right? And then I will review it. And if that program submission is up to par, you get all the points again. Right? If there are issues, I will then start dropping the grade. But I'm not most likely going to give you an option to submit a 3rd time. Okay? So we've got 2 shots. Right? And the last one will get maybe a more normal grade. For the most part, I will try to give you full credit. Unless there's something you simply ignored. If I said, fix this element of a program and you didn't do that on the resubmit, then I might dock the point. I will reserve that right. For the most part, I want to give you full credit. If it reaches what I would consider B- or better kind of quality, I'll give you full credit. All right? Late. If you submit late, I will take 1 point per day. Late. Right? So if a project is worth 10 points, that's 2 weeks. If you ignore it, not turn it in after 2 weeks, don't bother because it's already a 0 and you're not going to get anything better. All right? I don't count weekends. So actually, if it's due on Friday, you turn it in Monday. That's 1 day. Right? So you actually get weekends. Spring break is. That doesn't count either. I will take the 1 point and apply it, and I will note that in the response. Why? Because I can't have 20 of you decide you're going to give me 10 projects at the end of the semester. Do the math. That's 200 projects. If I give it 15 minutes per project, which I wouldn't at that stage, that's a lot of hours, which I don't have. You need to be on task to get through the semester. For yourself, first of all, and for me to be able to respond to everybody in a timely way. Because if you do have to do a resubmit, you want to be able to do that too. So things have to be turned in on time. So that's why not the attendance, but the late penalty will be strictly adhered to. Right, you might turn it in on Friday. I may not review it till Tuesday, Wednesday, or Thursday. I'm the teacher. You're the student. I paid my dues, but I also know I've got a lot to grade. So believe me, it's not like I'll be twiddling my thumbs in my office as well. If you have questions, please do come. Feel free to come to my office. My office hours are posted as a link off the syllabus. I'm often there other times. Don't come to the door and ask if I'm busy. I'll always be busy. Just come on in. And unless there's another student there. Elena's there, don't barge in on her questions, which I'm sure she'll have. And you can also shoot me an email. There will be times I might say, come see me. Because it's just more efficient for me to explain some issue than to try to explain it over email. If it's a yes/no question, shoot me an email. Are there any questions, housekeeping-wise, as the way this class is set up? So my appeal to you is stay on task. I don't know what else to say there, and I hope we can appreciate with the size of the group. This is all C++, and I've got Python and Perl and some COBOL to be done there. Like I said, I've got 30 students total, and if I would give 15 minutes per review, that's a day's work, just for this. Should be now. I'm going to find 8 hours, but I will. I will do that. So now I want to switch over to the Visual Studio introduction. How many of you might have used Visual Studio before? A couple of you. So hopefully this will be fairly efficient. My console machine is not happy, so I will have to set up my laptop here. It's in Windows mode. We'll see how this looks on the screen. I haven't put this on the projector. Let's see how this comes out. You're not rebooting. Oh, you are. Shut down? My computer would decide to be uncooperative as well. So much for just shutting the lid and coming down and being ready to go here. Well, actually, there we go. Okay. So, do bring up my webpage. Okay. I would love to change the perspective here. Do bring up my webpage because I have a link to useofvisualstudio.net, not too far down. Okay. And this is what we're doing. All right, so we're going to start Visual Studio, and we're going to do the traditional Hello World program, okay, with some modification here. Shrink that down a bit so that it fits. All right. So hopefully you can find Visual Studio.
Should I hit the lights?
What's that?
Should I hit the lights? Lights.
Oh, yeah. So that's not coming up very well.
It's coming up, but I think it would be a lot clearer.
All right. Yeah, it's probably going to be better. You don't need to see me. I can be a shadow now. I can make faces. I'm hoping. Why don't I see? Does somebody see Visual Studio? Wow, it was an icon. Do I like Windows 8? Here it is. Wow, wow, wow. Okay. Lots of stuff to cut out of my video. Okay, so, wow. So when you start Visual Studio, let's see, the startup page. Are you getting a splash screen? If you have a splash screen that first came up, okay, you can choose a C++ environment, and I would recommend you doing that. Okay. Guess that's not going to happen for me because I've done this before. So it's unfortunate that I can't use the console machine. And from the menu of Visual Studio, choose File, New Project. So that's what I'm going to do. So I'll toggle back and forth here. All right, New Project. Choose Empty Project. Are you guys with me? Yeah, okay, thanks for the vertical nods. It's helpful. Choose Empty Project. Don't double click it. I would recommend that you browse to your U drive. Do you have a U drive? You all still have a U drive, right? Good. I don't know what I'm going to do next year. Okay. At any rate, browse to your U drive and browse to I'm not going to my U drive, I'm staying on my C drive. But create a project in some location. So I'm going to call it hello and call it hello. I'm very concerned that I don't have my full screen. Not this, that's all right. All right? And then say OK. And on the left or the right, I don't know what determines that. I think most of you are seeing it on the left. You have a Solution Explorer over here. Okay, that's labeled hello, or whatever it is you called it. And what you want to do when you create a project. So project is capable of holding lots of C++ files. Right, that all together make ultimately an executable. All right. What I want you to do is right-click on the name of the solution, in this case, hello, and add new item. You can also get there from project. All right, and you want to click on C++ file. The two files that you will create will be C++ and H. Until we get to class development, you won't be creating H files. You will always have C++ files. You'll have one C++ file, it's essentially the driver, and then there are C++ H pairs that make class files. Classes, when we develop classes. But for now, in the next 3 or 4 projects, you will just be creating one file, and it'll be C++. All right? I should have given it a name. It's left as source.cpp. I guess we'll just leave it at that. But you will want to give the name to the file. Unlike Java, C++ does not require the file name to match class names. So you'll be very much at liberty to call it what you want. Okay. So I have an empty screen here where your source will go. So if you would, go back to my page here and copy this code. Include void name, standard, cout, hello world, standard end out, and brace. Try not to copy any more than that. And paste it in to the source window. At this point, I would like you to add one more line. Okay, so after the standard cout hello world, type in system parentheses quote pause quote parentheses. I discovered this morning that I had to put this in. I'm not sure why. Really, go away. Malware help is malware. Everybody at this point, are we good? Have a couple. If you misspell something, system, right? You will get red underlines as if it's like a spell check. Fix it. There's no sense in trying to compile this. It already knows there's an error. Okay. So if you fix it, the red line will go away. All right. When you're ready, you go up to Build and choose Build Solution. And your ultimate goal is to get build succeeded. If there are errors, you will get error messages. You can click on the error message and it will actually take the cursor to the source of the problem. So it's very, very helpful. But with the auto check already in place, you can pretty much tell if there's problems before you compile. All right? So after you build, now you can debug. And you can choose under debug, either start debugging or start without debugging. There used to be a difference, but that's why we had to put in a system pause, because there wasn't a difference. And I'll show you here for, well, it doesn't matter. If we didn't put the system pause in, I'll show you what happens. But anyways, we can start debugging and we see hello world. Press any key to continue. All right. If I didn't have this system pause in here, I'm going to comment it out, for example, build it. Any change I make, I have to rebuild. And now I start without debugging. Did you see it? You know, it was a program, it ran, it also finished. Done. Window goes away. All right? So it used to be that if you started debugging, that's what you would get, and start without debugging, you would actually get the same thing that we are accomplishing with system calls. Easy. Classic. Test your system with hello world. There we just did it. Okay. Are there any questions at this stage? I want to show you a little bit about debugging. Anything? The first thing I want to do too is put in using STD. Do you remember how to do this?
Yeah.
Namespace. Using. Do I put in the word namespace?
Yeah, it's a keyword.
Namespace STD.
Yeah.
Yeah. Pardon me as I relearn each of these languages. Remember, I'm grading 5 different languages this semester. 6 for Java. So what that does is allows you to have to, you can now eliminate this STD stuff. So using namespace, you're probably going to want to do that. All right. All right. That's all clean. You can compile and run that again and see that nothing happened. What I'd like us to do is create a couple of variables. Int I, J, This looks a lot like Java, doesn't it? There's one stage I ask you to read like 3 chapters, maybe it's 2 chapters. There's a lot of reading. You should be able to just flip through because it looks like Java. If statements are like Java. Now, Java is like C++. C++ and C preceded Java. Java stole it from the C languages. Okay, I equals I equals 5, J equals 11. All right, and C out, J divided by I. Let's see, I plus plus, C out. Hey, do you like the input output? Do you like the output? Or you prefer system.out.println. Thought maybe you'd like that. That's pretty cool. J divided by I. All right, so let's predict here what's going to happen just for fun. What's going to be printed out here? J divided by I. 11 divided by 5 is 2. Yeah, integer division, just like Java. Okay. I add 1 to I. What's this? J divided by I is now going to be 1. Okay. So let's check that out. That's this for fun. Build. Don't forget to build. If you forget to build, it will tell you. It's always good to be able to know the process even without having to be handheld. Okay. So 21 hello world. See the T1, 2, 1 is there. Okay. If you wanted that on separate lines, of course, what do you need to do? And down. Oops. You need the shift. That is the equivalent to the \n, the new line character in Java. And you can use new lines. All right, I can actually put that in. And I'll just show you, for instance, if I want to put in a new line character, I can do that. I prefer NL. And the reason is NL flushes the output buffer. It guarantees that that will be displayed. This, for example, when this is printed, and if I did some more computation, it's possible that this wouldn't be displayed right away. That is very problematic when you're debugging. Because you're looking at the code, and you say, okay, the program worked well down to this point. Oh, so the problem must be here. When in fact, it was down here because it didn't happen to show your output. Right? And L flushes the buffer. So never use this. You can, but I just highly discourage it. Okay. So now with those changes, build, debug, and now I have my 2 and the 1 separated. All right, that wasn't very exciting. Let's look at one more thing. Go over to the edge here, please, and click on that and make that little red dot, which is called a breakpoint. Okay. Now the difference between debugging and not debugging becomes apparent. If I and I don't need to rebuild when I do that. If I start without debugging, all done. Okay. If I start debugging, I have a little arrow to say we have executed up to this point, but I hit a breakpoint, so we'll stop. Okay. Interesting information showing up. You may find some of that useful later on. I should have just shrunk it. But here's some nice thing. If you mouse over, I move the mouse over I, notice that it says I5. I mouse over J. what did you expect? I have not executed j equals 11. What would you have expected j to have? In Java, what would j have had? A 0. Do not ever, 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 ever assume that you will get zeros. And C++ is simply an extension of C, which was designed in the 70s. And things needed to be efficient. We're not going to take time to put a 0 in it because you might put something else, like a 5 or an 11. Don't bother putting a 0 in it. So basically, this number here, I don't know if this is the same number you have. Does everybody have a different number? Do you have different numbers? Who has the same number? So the rest of you have different numbers? Yeah, so it's a random number because j has been associated with some memory location and you just simply get the bit pattern, whatever is there. It doesn't bother clearing it out. Okay? Now, we want to step. Okay, so up here are little icons that allow you to step one statement at a time. Okay, you have the ability to step one statement. You can step into a method. You can step over a method if you encounter a method. Do we have any methods? Yeah, cout's a method. Cout will be a method. Okay? And you can step out of. That's what. So you can step one statement. You can step into a method. You can step over a method, executing the whole method, or you can step out of a method. So, for example, I will simply step over. All right. So I am now down to the cout. And if I mouse over j, by the way, I can do it on any j. J is 11. Oh, we have a nice number now. And I is still 5. Okay. I can mouse over any I. Say I'm even up with the declaration. So it's currently 5. All right. If I step in, I'll just do it for fun. If I step into, I am now debugging the cout statement. You have no business even trying to debug the cout statement. You will find it unuseful. All right. All right. So here I am in the cout statement, or something. It's actually the less than operator, the shift operator. You say, "Whoops! I didn't mean to do that." That's why you have a step out. Okay. All right. And so you basically, when you encounter input, output, or most methods, just step over. And somewhere the window should have, if you could switch to the window. No, that's not it. Where's my window? Oh gosh, go away. Anyways, on your screen you can probably find, if you would shrink your C++, your Visual Studio window, you would find it. Okay? So stepped into again. Step over, step over, step over. There, it finally popped up. But you could have been looking at it as you went along. Right? That's the debugger. That I think you find it useful. You just throw in a breakpoint wherever you know it's good down to this point. Throw in a breakpoint and you can step. Obviously, you set up loops. Stepping through a loop that's going to run 10,000 times is not fun to step through, and you will want to continue. You do have that option right here. You can say just simply go to the next breakpoint. Execute now regularly to the next breakpoint or to the end. Yeah, I mean, I could start debugging. I could stop debugging. Start debugging again, and it runs to that point. I could just simply continue, and then it goes on. Right? So I could stop, look at some variables, and then go on. So you can put all sorts of breakpoints all around. Questions? So that's a nice feature of Visual Studio. Lots of environments have breakpoints, like you can do that in Dr. Java and a couple other places like that. All right. Any questions on what we saw so far? Now, final thing, is what do you submit to me through Moodle? I do not want your project. I want your source file. Right? So I left this be called source. Right? This is source CPP. Right? Over here in my search, my solutions explorer, source CPP. That's the one I want. Okay. Question is, where is it? All right. So when you are going into Moodle and deciding what file you want to upload, you need to browse to within your project and just get these source files. I don't want anything other than .cpp and .h. Don't send me what seems to be the entire project. You know why? Because I'm going to review this on my Mac at the command line level. A Visual Studio project's going to be doing me no good whatsoever. Let me also say that if you have the latest edition of the book, it will be talking about C++ 11, 2011 version. You're welcome to use that style of C++. I'm not happy about it. I would rather they hadn't made all those funky enhancements. It makes array processing look strange to me. I'm much happier that you would learn the older C++ because that's where most of the code is at this stage, and that's most likely what you would be looking at. If you're developing, obviously, you do go to the latest and greatest of the languages. But anyways, that's to say it doesn't matter. You don't have to use the C++ 11 version necessarily. All right, so I need to. So the question is, where is that source file? All right. So what you've got to do is drill down into the project. So you got to find the project, and I have to remember where I did that. It's my C drive. Now I don't remember. Recent places. Let's see. Huh, that's helpful. Okay, I did find it. Thank you for recent places. Apple did that first, right? Click on hello. So I went into my project. If I click on debug, I will actually find the application. That's the executable that you can actually distribute. Okay? It does hello world. But that's not what I want. Go into hello. Your project name actually creates a project and then a subdirectory that's also the same name. So go down to that one, and here it is. C++ source. So that's the file I want. All that other stuff, don't give me this. Don't give me a project file thinking that contains everything I already. There won't be anything there that I can use. Right? Or VC++ project. Right? I want C++ source. If I had this displaying my extensions, I would want to see .cpp. .cpp and .h is all I want to see. So that's the file you bump up into Moodle. They're not very big. Right? It's literally the text. You can edit this in text, Notepad if you want. And I don't care if you prefer not to develop under Visual Studio. If you want to use something else, Eclipse or some other platform, I don't care because you're just going to give me the working source file. I don't care how it was created. It just has to work. I'm going to test it at the command line of my Mac. All right? I was successful all last semester doing that. So you're not developing any GUIs. You are simply learning the rudiments of C++. This is not about Windows development, although it's all in there, but simply in libraries. You've got to learn this basic stuff first. Questions? Make sense? All right, so your first project, so your first project, as the page is getting unwieldy with all these additions, but you can choose 2.19 or 2.22. See, after all those additions, chapter 2 didn't change, except maybe a few page number differences. And so what is it? 219 is inputting 3 numbers, giving me the sum and the average. Average of 3 integers. If I averaged 1, 1, and 2, what should I get as an answer? Why would I want 1? Is that the average of 1, 1, and 2? Shouldn't it be 1 and a third? Yeah. So be careful with number systems. You know, with salt division, 2 integers dividing will give you an integer answer. An average doesn't have to. You have an average of integers. You're going to want a floating point number as your answer for averages. What's the standard deviation of that? Well, you would get would be 0 or 1. You've got to have, you know, the right data type. So be careful about that. All right. As you look at the exercise, the dialogue says different integers. I don't care if you get 1, 1, and 2. Don't write a whole bunch of code to say, well, you didn't give me 3 different integers. You gave me 2 1s. That's okay. So that's what I'm saying here. I will augment the exercises with these explanations. So be sure that you're looking at both. Okay. Yeah, so next week we'll talk about pi. I will spend a little bit on how I really mean for you to calculate pi, which is a deviation from the exercise. The exercise contains the Taylor series, is that it? To calculate pi. And I want you to assume you don't know the answer. I had students, put in pi, 3.141592, and then go through it to see how close they came to the. You don't put an answer in. You're not supposed to know what pi is. You're calculating. You don't know, so we have to figure out how we can gather accuracy. It's a numerical analysis problem. How do we converge to an accuracy that we want? So I will talk about that next week. All right, and I think the alternative there is the payroll program. All right, so I try to say it, but I'll find that it's easier to talk about it, and you can ask questions. So that's the kind of thing that we'll be doing in our sessions. And like I said, I will videotape this stuff, but I don't know how quickly I'll turn it around. So I wouldn't, if I were you, count on waiting for the rerun. Okay, come to the live session. Live performances are more fun than talking heads, right?